if he has any issues, he'll dial in again. So please be patient. First of all, good afternoon. I hope everyone's enjoying the same weather as we are down in Weymouth. Thanks for joining us for today's webinar on solar panels and roof space ventilation guidance. My name's Andrew Philby, and I'll be your host today. Today's webinar is presented by Craig Fyall. Now, Craig's our technical director, and he has over 20 years of extensive knowledge and experience in all aspects of roofing and construction membranes. This includes condensation control, air tightness, reflective technology, and building structure fire safety. Also in 2012, Craig led the design team in the specification and detailing of the first passive house 56-bedroom care home in the UK. So with his extensive product knowledge, Craig has helped to develop products that are now extensively used in the construction industry. Following the presentation, we will have a brief Q&A session where Craig will be happy to answer any questions that you have, but please direct those through the webinar into the Zoom chat box, which you will see on screen shortly. All of you will receive a webinar CPD certificate sent via email in the next 7 to 10 days. And most of you should have received your webinar sample packs, but if you haven't received those, you should receive them in the next 24 hours. So now's a good time to hand over to Craig to begin the webinar.
Andrew, good afternoon. Good afternoon, everybody. As Andrew quite rightly said, I'm kind of stuck in an airport at the minute, but hopefully it shall go seamlessly and go according to plan. This seminar today is looking at what we believe, and I think the industry, and I think there's probably a few people on this call today also probably agree, I hopefully agree with this, potential time bomb coming towards us in regards to the solar panel installations. And it's kind of great of the construction industry to think, right, okay, we're going to fit solar panels, let's go for inline solar panels. And there's a real disconnect in an awful lot of what we do. So it's to try and look at that and to give options, where we believe guidance currently is not there, and guidance needs to be there and needs to be a bit more robust. We've had discussions with NHBC who have been really engaging with an awful lot of what we've done, and we'll continue to do so. So this will give a brief sort of outline of it. It's there's only 28 slides, so it's not death by PowerPoint by any stretch. So hopefully it gets across the message. But any questions, please drop them into the chat box, as Andrew says. So again, bit about Permavent. Everybody, hopefully knows exactly what Permavent do and the importance of the important role we now play in the construction industry in terms of development of products, things like Easy Slate, Easy Roof there, which won the Queen's Award for Innovation, and then our fire-rated membranes. We've got a unique offering there in terms of fire-rated products as well, and thermal benefit products, looking at air tightness, etc., etc. So we have a real mix of materials now that we actually put into the marketplace, and sometimes you look at actually what products are available, and it's quite mind-blowing. The vast range of products, and more to come. So an awful lot of what we do, so we have been at the forefront of innovation and supplying roofing underlays into the construction industry for the last 16 plus years. Gee whiz, where does time go? We supply a range of technical services to the construction and house building contractors, along with a range of air open and vapor open, airtight, vapor permeable roofing underlays. Our seminar today looks at concerns surrounding recent changes to NHBC technical standards and other misinformation in the marketplace. An awful lot of it, and it'll be critical, created by manufacturers as well, regarding the installation of solar panels and the membrane directly underneath that, and how that should be sort of ventilated. I mean, to be honest, and a bit tongue-in-cheek, but the easy option for us would have been just to call one of our membranes a solar membrane and potentially confuse the industry even further by developing a solar membrane and changing the name of one of our other products there. So everything we do is there. Really proud of some of the associations that we have with people like the NFRC these days, STA, and certainly JCI, and everything we do is fully accredited. So, having been involved in the inception of vapor permeable underlays, or breather membranes as they now seem to be adopted by the industry, I believe we're positioned well to provide advice and comment on the recent standard changes The Partners in Innovation, and I think there's someone on the call today that will probably relate to this quite nicely, the Partners in Innovation document, who was heavily involved in it, identifies and was the catalyst of change for the British Standard 5250. Prior to that, there was a real bun fight in terms of what we knew, how we were ventilating roofs. There was ventilation only arguments, there was breathable membrane arguments, there was air and vapour permeable arguments. But I think over and above the work that was done at Caledonian University, what did come out of that document was that an air open and vapour open membrane, so air permeable membrane, makes a significant difference to the control of condensation in the roof space, in applications. The way we're currently going at the minute, we've got a real danger of going backwards and creating more and more condensation issues within roof space. Now, an awful lot of the thing with changes and the thing with guidance changes, it can take us, maybe 2 years to actually see that, or at the start of a guidance change there, and it could possibly take us into the winter of 2025, late 2024, 25, before we even see any detriment to this. So we'll have to kind of think about that and act now and move on. So 3 images there, 4 images showing condensation forming below the underlay and then dripping off onto the insulation as well. And that's due purely and simply down to insufficient cross-flow air movement. So cross-flow air movement fitted within there, and it is insufficient. It's not doing its job. Conditions, possibly. Installation, probably. Blocked, most definitely. So, there's real concerns about this problem and how we actually deal with it. And there is a misnomer in the industry that condensation is only present during winter months. Condensation can be present at any time. And people say, oh, the roof's heating up. It can still change, and conditions can still change as well. And controlling into a cold void, that warm air movement is significantly important. Talk about ceiling barriers across ceilings, etc. as well. What we don't want to see is the last picture there, is wetting out of the plasterboard. Plasterboard's horrendous when it gets wet, as everybody knows, but we'll start to see that wetting out period there. And that's when we know we've got a problem. Insulation then becomes inefficient as well. And often or not, that airspace will be blocked, and it will be blocked because we want to push the insulation in there. You speak to any house builder, let's get that insulation in tight into the eaves, because we don't want a thermal bridge, or a cold bridge rather, across that wall head, which is predominant on that. And it's amazing when you start to look at it and the mindset behind that. We don't think about ventilation, we think about preventing cold spots. Condensation is a combination of water vapour. And due to the way people now occupy houses, it's a massive subject of mine, very passionate subject, so apologies. But the way we now occupy houses, the way we occupy houses, and there is an absolute reluctance to ventilate the habitable living spaces. Condensation in most housing is inevitable. And as we adopt an increased levels of air tightness and energy efficiency within houses, condensation is increasing. There's no doubt about it. But sadly, the regulations regarding ventilation, background ventilation within houses have remained the same, despite houses becoming more hermetically sealed. I am an absolute tyrant for things like trickle vents, and don't think that they actually provide sufficient airflow. So we're creating more and more warm air within housing, and we don't want to use it. Bathroom extract fans are normally very, very inefficient in what they actually do. And the general movement of warm air has increased into the attic space, with traditional ventilation not able to provide enough consistent movement of fresh air. An air and vapour open membrane works and provides diffusion of warm air through that underlay to the outside, where the dew point will occur. 24 hours a day, 7 days a week, 365 days a year, and it's not dependent on any other factors. For example, wind movement to provide cross-flow ventilation as well, or blocked airspaces as well. The whole another manufacturer uses a point of the whole roof, and you're getting an even movement of air flow through the roof space. UKCMB then pushed the chart out a few years ago, which do quite a bit of work with these guys. Produced a chart, and it shows moisture and the main source of within the home, and it gives different living conditions. So working couples, retired couples, for example, families of four there, and how the climate is becoming, and how the climate is constantly changing, and how we're getting more and more of this wetter climate as well. In Scotland, we certainly get a share of wind, but it's certainly the climate, and work from or information from Met Office is basically the climate is getting wetter, and this phenomena will continue. And it's quite interesting when you look at buckets of water. I think it's very relatable to how many buckets of water are created. I think it's very relatable, and unless you're like my wife, who then asks a question, who's far too clever, and says, "How big is the bucket?" So it's quite important. But yeah, it relates to how much is created, and it has to come out the house. There's no difference between it. Significant differences in how we now live, and it plays a huge part in condensation build-up within the attic space. The cold void, as you often talk about above the roof, the living space. Even in the last 20 years since the initial Partners in Innovation work was carried out, house building has dramatically changed, with more complexity in roofing. 2 to 3 bathrooms are now common. Working from home is now very much the norm. And one thing that has not changed is house owners, occupiers do not open windows. The moisture load in the cold attic space has increased significantly on these changes alone. And we must think clearly around guidance and provide fail-safe solutions to construction that are robust in their approach for the longevity of the building. A good example of that is like the dry fix products now are pretty much the norm, and they took a long time to inset, but we start to move in a sort of the direction that is building better. But ventilation, there's no question that has to catch up within the living space. But how we ventilate that attic space is significantly different to 20 years ago to 25 years ago, and it's really, really important that we adopt a modern approach to that, and certainly air open and vapor open membranes do that significantly well. And this is a couple of examples of how this can go wrong, and certainly how low level ventilation can fail, and it's crazy that we think that a rollout rafter roll will provide a clear air path for and prevent the insulation from the insulation from closing off that airspace. And we expect the rafter roll to be able to do that. Well, I think both these pictures there, slightly tongue-in-cheek, show you that's not the case. And they're so thin these days, they're so engineered out that it's difficult. And the cost retrospectively of being able to solve the problem should you have no air movement within the attic space. How do you do it? Tile vents, remove the roof, then put a vapor permeable underlay on there. It's expensive. So let's get it right first time round. A couple of pictures here then showing cross-flow ventilation blocked in terms of the storage into the attic as well. And cross-flow ventilation requires that movement of air. So air in and air out, air in and air out. Normally always fitted along the long sides of the roof space as well. People use their attics for storage, and they want to store. The lack of storage within modern day housing is quite paramount, I guess, and people need to use that attic space to store their goods. And there's a couple of examples there, probably on the slightly extreme, but the middle picture there shows the point I am going on about, is that ventilation airspace, that ventilation flow, cross-flow eaves ventilation is blocked, and there's no doubt about it, it's blocked. So it's important to make sure that we ventilate properly. Air and vapor permeable underlays, ventilating across the whole roof space as well. The other issue with solar panels, and we've also seen this, there's a number of issues where the screws, mainly 600 mil, I think, 60 mil, that should say, misses the roof truss and breaches the underlay, because they miss the truss where they're trying to fix to, and it breaches through the underlay where the underlay is potentially at the top end of the drape as well. And we've second barrier of defence, the primary barrier of defence during construction, is breached. It's got a hole in it. And so water will ingress into that. Slates tiles on the roofs are only rain screens at the end of the day, and of course water will get through and find the path of least resistance. In Europe, where solar panels are installed, a batten and counter batten system is adopted, which significantly reduces the risk of the underlay being damaged, because it's creating that air in between the solar panel, the backside of the solar panel, and the actual roof underlay as well. So it's important. The introduction of that counter batten, to me, is really, really important, and it will also create that space for solar panel, for overheating a solar panels, etc. Just sort of going back, summed out, post the changes to British Standard 5250 back in the 2011, I think this was, or thereabouts. Condensation was still evident with the induction of more airtight housing coming in around the 2009 period. Drying out of houses was still a significant issue for NHBC and for house builders, and warm air vapour removal, cross-flow ventilation, was not working and functioning correctly. You know, so high moisture loads into that area was causing massive condensation issues. You know, always put down to the drying out period as well. During, interesting stat here, that during the winter of December and January 2010 into 2011 was the coldest for over a decade. And air and vapour permeable underlays demonstrated during that period how effectively they worked, with no recorded failures during that time. NHBC were the first to advise that an air and vapour open membrane could be used on cold attic spaces without the need for additional ventilation. Such changes were instigated due to the issues surrounding cross-flow ventilation and impermeable membranes. So as we increase the level of energy efficiency in modern day housing, the regulations currently do not provide sufficient background ventilation. Warm air is not removed at source, and trickle vents are ineffective with that. And this is the result. This is what we see. I never ever thought I would witness this. Early days, you would see this 2004s as vapor permeable underlays, as the market started to adjust itself and understand exactly the permeability and how to install and blah blah blah. But we are seeing more and more condensation coming back there. Cross-flow ventilation is ineffective, and it's not doing the job. You know, and a vapor air open membrane will, you know, diffuse consistently and do exactly the job it's supposed to do. So if you take that down, we used to talk in MVTRs, moisture vapor transmission rates, in meters square per 24-hour periods. So as an example, you know, a air and vapor open membrane might have 2,478 grams of moisture vapor transmission. A vapor permeable underlay, 1,785 grams of moisture vapor permeability as well. So there's difference there, but high resistance is over 1,000 because it's reliant on its airflow through the eaves ventilation as well. So, but food for thought there, I guess. Let's go back one. So short term, what's the danger then if we get it wrong? And I believe we are getting it wrong. So short term, substantial condensation during the drying out phase of the property, depending on which month the property is finished. Issues will certainly continue, and it will be blamed on that to start with. Oh, it's just the drying out period, don't worry about it. But the issues will start to continue. And depending on the complexity of that roof space, stagnant air pockets will exist. There's no doubt about it. Cross-flow ventilation becomes very, very ineffective if you start to introduce complexity to that roof space. You know, traditional up and over roofs that we used to always build, great, fantastic, it will work potentially depending on conditions outside. But when we start to introduce complexity into roofing, it's a completely different situation, and stagnant air pockets will exist. Medium term there, then it continues. Problems still continue. The roof starts to become an issue. The insulation becomes really wet, and it starts to become ineffective. We then start to see things like plasterboard starting to wet out, and plasterboard staining starting to come out. And longer term, there's a massive problem, and it's who then is responsible for replacing that. Who is going to put all this together and remediate this? I read somewhere that NHBC currently the top 5 claims in NHBC at the minute, roofing is in the top 5. So that doesn't categorise it all down to condensation, by the way, but within there, roofing failures are within the top 5. So there's an issue there. Somewhere in the region of around about 6.8 million quid a year it costs to remediate problems. Within there, there'll be condensation problems. Within there, there'll be inadequate fitting. There'll be dry fix problems, etc., etc. But it just kind of highlights the problem that exists. So we've undertaken quite a bit of work on this. We've looked at how do you create condensation risk on different roof coverings with different membrane types. And listen, we're happy to engage with any house builders. We're happy to engage with anybody on this and demonstrate the different condensation risk analysis and how you can factor that in, and certainly looking at an air open, vapor open membrane significantly reduces that risk. Oh, apologies, jumped a slide there. So let's look at roofing then. So roofing has become quite interesting, and it has become more and more, I guess, development of roof trusses are now, structural loadings are better than they've ever been. We understand roofing a lot better, and from that has allowed us to become more complex in our designs of roofing. And we must consider that complexity of the roof and how adequately we can ventilate that. Mass moisture migration will build up if there's no clear air path provided. And there's 3 examples here above that are standard house types for house builders. So it's nothing fancy. These are standard house types. And you can see the complexity. When you start to introduce valleys, hips, abutments, all these things, crossflow ventilation really, really struggles to cope with it. And you're looking at air in and air out. In this example here, in the middle here, how does that operate? It's a very, very complex roof. And how do you gain sufficient air movement within that? There we go. So another couple of examples here, the slides coming up here of difficulty in crossflow ventilation. So here we've got this example, and the detailing on the roof will give this problem. So crossflow ventilation here, we've got solar panels fitted here. We're looking along this line here, and then across the back. What about this detail here? How do we ventilate this sufficiently? My concerns here on this roof, in this valley, it'll condensate. There's no doubt about it. Why? Because I'm looking at where the bathroom's sited here, and we will see condensation, because that bathroom fan, I can guarantee you, will be ineffective, and it won't allow enough out. So it's coming through that a rate of knots through that plasterboard there. Mass moisture migration into the attic space. Ventilation will not cope with it. Another example of here why crossflow ventilation or eaves ventilation doesn't particularly work well in certain circumstances. So roof here, we've got an array of solar panels, as NHBC talk about here. We would ventilate along here and then along that side of the roof as well. How complex is this, and how can we guarantee airflow through here? Very, very difficult. You end up with almost like a tunnel effect in here, and the air might come in, but we've got to get that pushed out. So it's coming in here, but it's not effectively going to come out the other side as well. Massively important of how the guidance is slightly difficult to umbrella. Umbrella all roofs are the same. They're not. There's no doubt about it. In this area here, we talk about an array of solar panels again, and what I'm highlighting here is there's sufficient area. If you take the square meterage of that roof space, remove the solar panels, the square meterage off the back there, there's more than sufficient ventilation movement through a air open, vapor open membrane as well. And if we then introduce high level ventilation to that, dry fix products are available, then the roof will ventilate quite nicely, and the solar panels will not give an issue to that. So crossflow ventilation then, and an array of solar panels. I've chosen these 2 words because there is confusion, and it's been created by the phrasing an array of solar panels, and how do we calculate what an array of solar panels is. And we've had some really interesting conversations with NHBC on this particular subject. So here, for example, is particular job here, an air open membrane used on here, and look at the square meters of an air permeable roof covering, so a standard interlock tile there used, and look at the spacing that we have in between there, that roof will ventilate superbly well using an air open membrane, and superbly well without the need of cross-flow ventilation. The danger here, if we fit cross-flow ventilation in here, eaves ventilation and a solar membrane, an HR membrane, high resistance, then how does that roof actually ventilate? And we'll have considerable condensation problems. There's no doubt about it, because the roof guarantee that the insulation will be pushed so hard into the eaves that it will choke and throttle the any ventilation path there, and any clear ventilation path as well. So really, really important that we understand this and we start to look at roofs and certainly designs of house types, which is something we've done and engaged with a lot of house builders, and it's been very, very successful. Again, an example of how ventilation can be impeded by waiting on just cross-flow ventilation. Yeah, we'll have to think cleverly. We've got to think modern as well. So NHBC guidance at the moment is, regardless of the roof covering, whether it's air permeable or air impermeable, we have to treat that, when we have solar panels on the roof, as an array of solar panels. We have to treat that as air impermeable and ventilate in accordance to how we would ventilate a metal roof covering or a fibrous cement roof covering, a type HR. So again, when I was chatting to one of our sales guys the other day, our technical sales guys, and he was saying, there's massive confusion because manufacturers coming and classifying things as an HR membrane, an impermeable membrane, and calling it HR just to kind of fall in line with this guidance, and creating things like a solar membrane, which to me is very, very confusing for the industry. Because I look at a solar membrane and I would say that, well, the solar membrane must have something to do with heat. It must have something to, over and above that, it's benefiting the solar panel, but not just taking a membrane and calling it something else. So it's massively important that we get this information right, and massively important that we ventilate right as well, and don't go backwards with it, and don't be frightened to challenge. Again, more guidance from this, and as I say, NHBC very, very engaging with them on this subject at the minute, and really interesting, from what perspective they're coming from, and again, how as manufacturers, how we can assist them in making the correct choice, but not making the choice to go backwards as well. So, some real good guidance in there, but looking at every roof type individually is quite important, and as I say, the complexity of roofs these days is massively important. So yeah, so what is the choice? Yeah, so we often talked about no ventilation required, cold roof spaces, and that is still very, very relevant. But what happens if we say, okay, an air open membrane, so we've got the whole roof allowing air movement in, out, vapor permeability very, very low, and we open the ridge up and we say, okay, we'll ventilate at ridge only, 5,000 millimeters per square meter. Just about every house these days has a dry fixed ridge fitted to it, and 99.9% of these dry fixed ridges are ventilated as well, and providing 5,000 millimeters per square meter of airflow as well. Massively important, and as is a consistent drape on that underlay as well, to create that inner channel there as well. One of my concerns is the overheating, the heating of that airspace as well underneath the solar panel. One could say that there is no condensation risk where the airspace is heated as well, and solar panels do omit heat and do let that off. There's a massive talk at the minute about loads of solar panel companies saying, yeah, our panels are breathable, don't worry about it, they're very permeable, you'll be okay. I've yet to see, and if there's anybody from solar panel on here today, I've yet to see any real guidance and confirmation that a solar panel is fully permeable. But yeah, stand to be corrected on that one. So summary concerns and looking at this is, the use of a type HR high resistance, as I talk about, this has now come back into the fore. It's like air permeable underlays as well, APLs, with ventilation below that membrane will create condensation issues in the cold attic space. It's all about below the membrane, the ventilation below the membrane, you know, and above the membrane as well. Massively important, and we've got to be clear on the guidance. A type low resistance underlay with even a high level ventilation will not potentially provide the solution into attic space condensation where solar panels are used. But the solution is, without a shadow of a doubt, and condensation risk analysis tells us that an air and vapor open underlay with high level ventilation where solar panels are installed will certainly resolve the problem and not put us backwards in terms of our decision, and more so condensation within the attic space. Air and vapor open, there's the kind of detail that we're talking about there. So thank you for listening. Hopefully that's not been too noisy in the background, and hopefully that's been putting a message out there. We're really happy to engage with anybody on this subject further. Andrew, I'll hand back to you for any questions. Thank you. Hello.
Hi, sorry about that. It would help if I turn the sound back on. Yeah, very informative, Great, thank you.
Okay.
After all your comments, we've had the first interesting question. We should obviously, do Permavent have a solar membrane?
Brilliant, brilliant. Someone's obviously been listening to my rants about solar membranes. No, we don't. Or yes, we do. We do, and it's called Permavent Apex. It's not changed its name, and we don't have solar membrane alongside it or anything like that. Because it does the job, and that's certainly our advice where we are using that. We haven't changed, you know, and possibly been a slightly mischievous there, but we haven't just changed the name of a product and called it a solar membrane, and it's an impermeable membrane. We have a product, MB145, that we could call solar membrane tomorrow, but the guidance isn't right, and that's the most important thing. So yeah, we don't have that, or we do in terms of Permavent Apex.
Okay, but we're not trying to gain advantage through it. Okay.
No.
So, someone said, what difference does the air permeability of the product make?
Significant, significant to the overall air movement through that, and the movement of warm air out of the attic space, you know, before it has a chance to condensate. It makes a massive difference. And you know, anybody that was involved in PII, Partners in Innovation, there was massive push towards air permeable membranes back then. Did I fully understand it? Probably not. I think there was people more far cleverer than me back then, you know, that pushed that message. But they made, and the research work done then demonstrated that as well. You know, complex to make, possibly why we don't see too many on the market these days, but offer the significant difference, a significant difference. So that the MVTR rates, the moisture vapor transmission rates, are you know, significantly more than what it would be on a standard vapor permeable underlay. Yes, so they do make a difference, Andrews, no doubt about it.
Okay, another one. Do you require vapor control layer and AVCL to make this work?
It depends on what, you know, it depends on the roof type. So what are we looking at? So we have to, you know, it's a very bold statement, because there's different types of roofs. And so you have warm roofs where a vapor control layer is required because an AVCL is required on a warm roof structure in accordance with BS 5250. On a cold roof, there is no vapor control layer required. However, you know, the people talk about vapor check plaster boards and stuff like that. They're ineffective because they're not a continuous layer. But what does make a difference is a air barrier, you know, from an air tightness perspective. So from air tightness, what we're trying to do, we're trying to keep, you know, the house as airtight, as hermetically sealed as possible in the livable area. Above there, everything is deemed to be outside. So what an air barrier does, something that doesn't have the same vapor resistance as a vapor control layer, for example, does make a difference because it controls, you know, and allows it through at a steady rate. So yeah, there is no requirement for it on a cold roof. On a warm roof, yes, there is.
Oh, okay. That was going to, the air tightness was going to be the next question, but you've covered it, Craig. So in layman's terms, what is the difference between, you talk HR underlays and LR underlays? What is the basic difference?
Sorry, Andrew, I missed that. There's a bit of background static here. Could you just...
Yep. I was saying in layman's terms, you discuss HR and LR. What is the difference between HR underlays and LR underlays?
So this was something that came out in the guidance a number of years ago, and it talked about calling high resistance. So things that are completely impermeable. Well, nothing is completely impermeable from glass. So high resistance underlays have a figure of, the benchmark number was 0.25 MNS per G, and anything above that would be deemed to be high resistance. So it didn't allow moisture to escape quickly enough. Anything below 0.25 was deemed to be low resistance, and that's where these two phrases, HR and type LR underlays, come from. Yeah.
Okay, I'll run through these. I think people are conscious of lunch, but a couple of questions have just come through on the QA tab. With the increased moisture passing through an air and vapor open membrane and potentially getting trapped under the panels, how does this get ventilated without a ventilated counter batten space?
That is a pretty good question. It's also a bit of a misnomer as well, depending on, that's why I talk about array of solar panels. So what I'm basically talking about there, warm vapor will find the path of least resistance, and it will come to the path where it's naturally drawn out. Behind the panel, there won't be sufficient buildup. Behind the panel there is warm air within that. So from a condensation risk, no, there isn't, because the warm air doesn't just go to, oh, there's a solar panel, let's go at that point. It will be drawn to the path of least resistance. That's why high level ventilation is so effective, because it's working on that Venturi effect, that low pressure draw at the ridge. So yeah, no, there is no, on condensation risk analysis, there is no issue in behind that panel.
Okay, and a question I'm sure you've never been asked before. What would happen if moss builds up on the roof covering over time and impinges on the level of air permeability, which is, today is a good question with the changing weather conditions.
Yeah, there's there is no massive effect to that, and there was some light testing done on this a number of years ago, and it's a bit of a slight red herring, because the interlocks in the tiles are covered by each other. So the interlock in the tile still allows that vapor to come out, and moss on the roof. Will it possibly? It will have a slight effect, but overall, no, because there's a built-in factor there of still getting the permeability of it. BII did lots of work on this as well, looking at what happens if the scenario of leaves, what happens if the scenario of moss build-up, etc. It doesn't make a significant difference to it. And you should also look after your roof and clean the moss off of it.
Okay, and the last one, because I'm conscious you have planes to catch and I'm sure people want lunch. Can we use a counter batten with your product?
You can use a counter batten with the product, yeah, without a doubt. Massively important. One thing, why in Europe do we use counter battens on solar panels? Because we want that space, we want the protection to the underlay. I think showed examples there of breaches within that underlay, and created by the fixings. So if you miss the roof thrust, bang, you're right into the underlay, job done. Your underlay is ineffective and has a hole in it. So yeah, I think counter battens will become mandatory. Is that the right word? Will become important to the installation of solar panels.
Okay, no, that's brilliant, Craig. We'll call it today there. Thank you very much on behalf of Permavent for all of your attendances. The technical stuff, technical information and case studies, please visit our website, which is www.permavent.co.uk, and do pop on the LinkedIn and Facebook pages and give us a like if you want to receive regular news and updates. So thank you again to everybody. information will be sent through to you. And if you have any other questions, please send them through on the website question box. Okay, thank you, Craig. Thanks everybody for joining.
Thank you.